for being so patient. We'll get straight into it now. Okay, so today, just one thing before we get started. There are help sessions that are starting this week. So help sessions are like optional drop-in classes. You don't have to book, you can go there and get help. They're bring your own devices, like bring your own device sessions. They start this week. There's a whole schedule. You can find it on the website. There's also a post on the forum about it. So if you want help with anything content related, go to those. I'm going to do a bit of a recap of, I'm going to start with a recap of Structs and Enums, and then we'll go to an application with Structs and Enums, okay? And then we're going to do something new. So let's go to my code. All right, so last week, we had a look at this kind of thing with Structs. Hopefully you all kind of remember this and can see it properly. So up here, we've got a struct definition. When we have a struct definition, we're allowed to design this ourselves. So when we design it, we decide, I want a struct student to have all of these different fields. Okay, so for this example, we've decided a struct student will have a first initial, a last initial, an age, and a lab mark. And when we do this, this is just like a blueprint. It's not until we're down in the program here, and I've declared a variable. Now this variable that I've declared, it's of type struct student. So this is the type. Just like if I declare int x, int is the type, here struct student is the type. And Brianna is the name of the variable, just like here x is the name of the variable. So when we do this line here, we actually get this chunk of memory that we can store our variable in, and that chunk of memory is big enough to put all of those fields in. Okay, so down here, if we want to actually access the struct and put data inside it, we use this dot operator. So I take the variable name and I say, variable name dot first initial, and I can go and set the first initial inside this struct, that data member, to be B. I can do the same thing with all of the different members in this struct. I can set the last initial to be K, the age to be 21, and the lab mark to be 9.9. And they're all stored together in this one variable and this one collection. Okay. But we can access the individual components inside of the individual members. Does anyone have any questions about this so far? So we did this before. Is this all right? Okay, now, once I've got something like that, I might want to sort of do calculations or modify some of the data inside it. So I could say Brianna.age equals Brianna.age, +1, for example, and that would go in and it would update the age to 22. Okay. Now, when we go to use this struct, and right now the struct doesn't probably seem that useful because, yeah, we've got one variable, but we're still setting all these individual parts. When I need to print it out, I need to go and print out all of these individual parts with printf %c for the first initials and last initial, %d for the age, %lf for the lab mark. So you're probably not seeing a huge advantage at this point to just having all the, separate variables. But we'll see later today when we do our new topic functions that this is really nice because it allows us to pass around this information to different places when we need to do that as one little, like having a suitcase that you can carry things around in rather than having everything just everywhere. Okay, now down here I've written some more code. We've got a second student. This drawing's in the way. Let's get rid of it. We've got a second student. So again, when we do this line here, we get a chunk of memory big enough to store all this information. And in this example, we're not hard coding the data in this struct, we're letting a user type it in. So again, we need to, look, I've done this with 3 scanfs. You could have just done it with 1 scanf, but you need to scanf all the pieces in. So I've got a %C for the first initial and the last initial, a %D for the integer age, and a %LF for the double lab mark. And like we always have to do with scanf, we put this ampersand here, just like we always do. Okay, so if I run this over here, and if I'm in the right directory, let's just double check I've saved it. Things are going wrong today. Okay. So it's going to print out all the stuff about Brianna, her initials, the age, and the lab mark. So now I'm entering the first and last initial. Oops, doesn't matter. 123, whatever. 4.1, etc. So I can enter that information and use scanf, but I have to do it for all the different members. I can't just do a scanf the whole student at once. Okay. So this is an example of structs. Sorry, the tech guys here, we'll just keep going, right? Yeah, I think we'll just keep going with what we've set up. Okay. All right. So that's structs. Okay, and we're going to do some more with structs today, but that's just a bit of a recap. The other thing we did was enums. So enums look a little bit like this. Now, sometimes maybe people who've done other languages get confused about what these enums are. They're basically just you're coming up with the name of a type and you're giving it a set of constants that you can assign to it. So we're really thinking here hash defines, like a fancy hash defines that you can use for a set of integer values. Okay, and you get a little bit of type checking. So I'll tell you what I mean by that in a moment. So let's go to our enum example that we looked at the other day. But maybe I've added a few more things. Okay. So here I've got these enum weekdays. So if we didn't know enums, we could write it instead. We could just have hash define mun is 0, hash define chew is 1, hash define wed is 2, or whatever. We could go and define it all like that. That's a little bit error prone. You might accidentally, there's potential to accidentally put the same value for 2 things. I mean, I've done all that kind of thing before. And they're also everywhere. This is a nice compact sort of way of doing it. The other thing is it gets you is that it does some type checking. So if I've got this enum weekdays, if I create an enum weekdays variable, I can only assign it the constant values. I can only assign it constant values from this set. So I can say day equals Thursday. I can't say day equals November. The compiler is going to complain. Whereas if I just had a whole bunch of hash defines, the compiler wouldn't know the difference between, you know, any of them. They're all just sort of integers. So that's one nice thing. It doesn't help you from making all sorts of mistakes you can make, but it helps a bit. All right. The problem with these enums that I see is that, you know, if I try and print this out, let me just comment out this part. For now. If I just print it out, it can't print out Thursday or Thur or anything like that. It's just going to print out the integer that it represents. So by default, Mun will be 0, Chu will be 1. Like in the order of how you've defined them, they'll just get 1, 2, 3, 4, etc. So if I try and print out my day, which I've assigned Thursday to, it's going to print out 3, which, you know, if we've got a program and the user asks what day it is and we say 3, meh, the day number is 3. And if we want to print it out as a more meaningful message, like Mun or Monday or something like that, we've got to do the coding ourselves with something like this. Okay, so I've got this if statement. I can go and say, well, if the day is equal to Mun, print Monday, else if it's equal to Chu, print Tuesday, etc. Okay, but these enums will come in very handy once we start putting more things together. But that's kind of all they are. They're just a kind of nicer way to do sets of integer constants. Does anyone have any questions about enums before we move on? Okay. So I've looked at that. Now, we can start combining things now. We can have a struct and it can have an enum member. So here I've got my struct student and it's got 2 members. One of them is an enum. Okay, so I've got this enumerated type that I've called student status. It can be enrolled, withdrawn, leave. I'm not sure if you can go on leave. I just made this up. And in student, we can store a status and a WAM. And we can just do everything as normal like we would do with any kind of type we have. I can declare my struct student. I've got my variable name. I can go and set the field inside, in this case to be enrolled, and for the WAM to be 95.9. All right? So I can have members inside my structs that are enums, and they're just treated like any other type, right? Any questions about this so far? Now we did start the other day online. Does anyone remember what we started? An example. Okay, we started a Pokemon example and I've added a lot of stuff to it. Now there's going to be a lot of code, and if you're not code speed readers, you may not be able to read every single line of code in here. Don't stress about that, because I really want to use this as an example of something we do with the next topic as well. But we defined a Pokemon type enum and we added some stuff. I added a few extras. I added fairy and normal, I think. But you know, we came up with these different types. There's probably more. This isn't 100% accurate. If you're a Pokemon lover, I apologize. And then we've got our struct Pokemon. I think people suggested defense and attack and 2 different types of, you know, you might be a fairy and a grass type. I don't know. That's what we've got here. And hit points, I don't know if that's a thing again, but we've got some an integer member, some double members, and some enum members in this struct to represent a Pokemon. Now down here, I've created a Pokemon. So the name of my variable is Jigglypuff, and again, these are all fake numbers. Don't come for me. I'm giving Jigglypuff all these different member values. I think maybe they are fairy and normal, but doesn't matter. So this is how we'd have to set it all. And we know already, if I want to print out any kind of enumerated type, I'm going to have a lot of code to do that. So when we go down here to print out all the details about my Pokemon, it's quite long because I'm printing out all of the stats I'm printing out the type for its primary type, and I'm printing out, or I've basically copied and pasted all this code down here and done it again, but for the secondary type. Can everyone see how much kind of, we call this duplicated code. Does everyone agree? Like I've basically copied and pasted and changed something. And this function is really long. I mean, yeah, this main that I've written is really long, and all it's doing, let's run it. All it's doing is printing out that, and we've got all this code, right? So imagine if you had a whole program and there were more than one Pokemon and you were printing, like this gets, the code becomes really unmanageable and you have lots of duplication. So today we're going to find a better way of doing this kind of thing where we don't have to copy and paste and just change something. And we'll come back to this example and we'll clean it up so it's a little bit nicer. Okay. So to do this, the thing that we're going to learn about today is functions. So hands up if you've seen functions before. Oh, in this course. Yeah? Where? Who wants to call out? Yeah? Python. Oh, in Python. Okay. In this course, who's seen functions in this course? Yep. Int main, exactly. Int main void. That's a function. So all term, we've been writing functions. It's just always the main function, right? Yep. And that's exactly right. We've been using functions. Every time we use printf, we're using a function that is in the standard library. So it's a function somebody else wrote. And we're using scanf, a function somebody else wrote. And we're writing main ourselves. Well, now we're going to learn how to make our own functions other than the main that we'll be able to use again and again, just like we use printf again and again. Okay? So that's what functions are, and that's what we're going to do in this part. And we're finally going to get to find out what void and return mean. All right. So So what are functions? Functions are independent, reusable blocks of code that perform a specific task, like printf. You want to print something out, you use printf. You can reuse it, you can call printf whenever you want it, and it kind of does one thing. The benefits of using functions are that it breaks down your program into simpler, more manageable pieces, and it makes it easier to read and understand. So you probably, hands up who's gone and looked at the code for printf ever? I don't recommend it. Yes, there is one person. It's quite complicated and it's long. Now, if you have to write that code every time yourself, you're going to have code with all of this complicated printf code littered all through your program, and it's going to make your program very hard to read. Instead of that, you just get to write printf, %d or whatever, which by now hopefully is not so cryptic as it might have been in the first week, right? And it makes your code a lot more easy to read, and it breaks it down. That code for printf is somewhere else and you don't have to keep looking at it and getting confused by it. It avoids duplication. You don't have to rewrite printf every single time you want to print out something. You just call that function. And it hides the implementation details. So only one person in the room has, actually I've looked at it too, has looked at the printf code, but you all can use printf. That's the value of functions. You can use functions that other people have written as long as you know what those functions do. Okay? And you'll then even be able to write functions yourself, and even though you wrote them, they might have been tricky, and then later on you don't have to keep thinking of those tricky details when you're just using them. It also allows us to test and debug smaller chunks of code. So if you've got a bug in your program at this point, you're probably not going to be hunting down the people that wrote printf and saying that it's their bug, probably. And if you write functions and test them well, and you've got confidence that they're working, you know, you can be fairly confident that the bug isn't coming from that function that you wrote. Not 100% confident. So I've talked about this. You don't need to have seen all the code for printf or any function to be able to use it. You just have to know what inputs it's expecting and what it's going to do and return to you. Now, when we want to use a function, we do a function call. So every time we write printf, %d or whatever, we're calling the printf function. That's the terminology. And we have to pass in the correct sequence of inputs. So we have to pass in like a string with maybe a %d or something in it, and then we'd have to pass in, you know, the variable names or whatever whatever we're trying to print. And if we don't do that properly, it's not going to compile. You know, you've got to pass in the right things. And we even learnt, I think last week, that scanf returns a value of how many things it read in, and we can store that as a variable or do something with it. And we call that a return value. Okay. So here we've got a function prototype. So notice, well, you might not notice, but I haven't got the whole code. I haven't got all the if statements and all the logic implementing this function. This is just what we call a prototype. It's got the name of the function. So this function is called maximum. Then I've got the parameters. So these are the inputs that the function needs. So if you want to use this maximum function, when you call the function, you've got to give it 2 integers. All right, and then the maximum function is going to return something. It's going to give back kind of like an answer, a value that you'll be able to then use in your program. So it's like, if I want to, who wants to be the maximum function? Who wants to volunteer to be the maximum function? You've just got to call out one thing. Okay, yes, okay, we've got a maximum function down here. Thank you very much. So if you're the maximum function, I can call the function by saying, you know, give me the maximum, but then I can't just leave it at that. Tell me the maximum. I have to give the 2 numbers. Give me the maximum of 7 and 10, and he's returned the answer 10. Okay, so I've said maximum 7 and 10, he's returned the answer 10. I then know it's 10. I didn't have to work it out myself. The function did it. And I can now use this value 10. So thank you very much. And yeah, this is what we need to do to call functions, right? Obviously, and when you start using libraries more, because we'll use more library functions other than printf and scanf as the course goes along, often you'll be looking at these prototypes to get an idea of what the function does and how you need to use it. There might be additional sort of documentation as well in words, but this really shows you how to use the function. If we're writing these functions ourselves, obviously we've got to write the code as well, so we'll see that in a second. So that last function had 2 parameters, so 2 inputs. So you have to define what arguments or parameters you're going to have. Sometimes, if you don't need any inputs or arguments into your function, it'll say void, right? And we'll see some examples of that. But where have you seen this already? Void. Yeah, int main void. So that's saying the main function, you're not giving any inputs to the main function. It's just running without you giving it any inputs. But we'll see other examples of that as well. And you can also have a return type of void, which means it doesn't return a value. Okay, so let's look at this maximum function. Let's look how we can use it in our program and how we can implement it. So it's over 2 slides. I'm going to go to the code. Okay, so here is the whole sort of program, and we've got this one function maximum. So the way we lay it out is we put this prototype up the top. And I'll talk about why we have to do that later, but we've got the prototype up the top, then we've got our main function, and then we've got the actual code for the maximum function that we've written. Okay, this is how we like to lay things out. Now, if we look at the maximum function, it's got two inputs, x and y. It's got code that's trying to work out which one's bigger than the other one. And you know, to do that, it's got this kind of logic. It's assuming that the biggest one is the biggest one is x, and it's putting that in max, and then it's doing some if statements to work out, you know, which one's the biggest. So the kind of code in here doesn't matter as much as the fact that it needs to work out which is the biggest one and then return this answer, right? What it needs to return has to be of type int to match this function prototype. So, and I'll trace through this. It determines which one was bigger, puts the value in max, and returns it. And we've seen this word return before as well in our main function. So every time we get to the end of our main function, the way we've done it so far, we're always returning naught, which is an int, right? Why do we do that? We don't really need to know it so much for this course, but people tend to ask. When we return naught, it typically means from the main function, returning naught is like an error code to say it ran successfully. So basically kind of like the operating system. Okay, but let's go through this code. So we know when our program starts executing, it starts executing from the main function, and it starts at line 1. Well, not line 1, but it starts here at the first line of code inside main. Now, inside the main function, we've got a variable called num, and here we're giving it the value 7. Okay? Then we keep going. When we get to here, we're doing our function call. We're asking what's the maximum of 10 and num? And we know num is really 7, right? So what happens here is we stop executing the main function. We just sort of pause here and we call the maximum function. We pass in the value 10, and num is actually 7. So we're passing in this example, 10 and 7 into the maximum function. And the 10 ends up going in the x parameter, the 7 ends up going in the y parameter. So down in the maximum function, we've got x, that was passed in as 10, y, that was passed in this example as 7. Okay, is everyone happy to hear? All right. We've also got another variable in this maximum function called max. And the logic here is we're putting x into max. Let's just run through it. We're executing this line. We're now checking, is x less than y? Is 10 less than 7? No. So, you know, the max isn't y, we can leave it as 10. So by the time we get to here, we've got the biggest number in our variable max. Okay, does everyone agree with that? And then we return it. Now, up in, let me draw a line here, up in the main has its own variable that happens to also be called max. And it goes and stores this value of 10 up here. So we've returned the value of 10, and the main function has stored it and has it to use themselves. Once that function has finished and returned that value, all of these sort of values it had, all these variables, they don't really exist anymore. The system can go and use those resources for something else. Okay? And when we return from this function, we begin execution on the next line. So it'll start executing here, and it's going to print out 10, which is the max. Okay, so this is how the control flow works when we're calling functions. Yep. Oh, does anyone have a question about this? Yep.
So no matter I put the code of the function definition over the main function or after the main function, it doesn't matter.
I just got a question about where we can put the code for the function. So I'll just go through that in a second. That's a good question. But before I do that, I'll just talk about one more thing. Now, we can call this function as many times as we like. And I don't even have to store the result in a variable. I could just do it all in one go like this. I could say something like this. And this, when we get to this line, it will go call maximum. It's just passing in 1 and 99. We hope maximum returns a value of 99, and that's going to be the value that gets printed. Whatever it returns, which we're thinking is going to be 99, right? Okay. All right, any questions about that before I talk about where we can actually lay these things out on the page? Does it make sense? Okay, so when we compile, the compiler goes from top to bottom. So if I get rid of this, just say I comment out this prototype, as it's compiling, it gets to here and it sees this maximum and it thinks, I don't know what maximum is. I don't know what you're talking about. I don't know if this line compiles. I don't know if you're using this thing properly. Okay, so we get this error. Has anyone seen this error before? Implicit declaration of function maximum. Or has anyone seen a similar error? No, that's very, very good. Yeah?
We need to put like the int maximum before the main.
Yeah, because we didn't put int maximum before the main. We didn't put the prototype. Sometimes if you forget to hash include the std.io library, has anyone ever done that? It'll say something like that about implicit declaration, we don't know what printf is, okay? It's saying, I don't know if this maximum, I don't know what this is. If we put this in, the compiler knows, okay, there is something called maximum. It does take in 2 integers and you're using this correctly. That's what that prototype's for. Now, the other alternative to having that prototype up the top is just having the function up the top. Because then when the compiler is compiling it in order, it sees the whole function, not even just the prototype. And that's going to work. That's fine, it still works, but style-wise in this course, we prefer it the other way. Why do we prefer it the other way? Well, this is a very small function with, this is a very small program with one function, but if you've got a larger program and there's lots and lots of functions, you want them at the bottom. Because remember, we're using functions for abstraction. We want to be able to go and look at the main function. We want to be able to see that first, get an overview of what that program's doing, and only go down and look at the maximum function, for example, if we want to see a particular detail, right? We don't want to go and look at all the fine details of things to start off with. We want to look at the main, go look down at the functions if we need to. So we want you to do it like this. Okay. All right, here's an example of some more different types of functions. So we've still got int maximum in there, but we've got a couple more here. We've got print stars, where the input is int, but the return type is void. We've got print warning, where the input is void and the return type is void. So what's going on with this? Well, when I'm doing the maximum function, I'm kind of asking a question like, what is the maximum of x and y? And I'm expecting some kind of result to be returned to me that I can then use in my code. When I'm doing something like print stars, it's more like I'm giving an order. Go and print these stars. Go and do something. And I need, in this situation, I'm giving input because I'm saying, well, go and print 10 stars. Go and print 100 stars. But I'm not waiting for that function to return information to me. I'm just expecting it to go off and do something. And then, you know, I don't need any more information back from it. If I've got this print warning function that has void input and void output, or return type, this doesn't need any input. I just say, go and print a warning. It goes and does something. It doesn't return any information to me. So let's have a look at a program with all of those functions. Aha, simple functions. All right. So we've got this part up here. We're still calling the maximum, and we're still expecting that the maximum of 10 and 7 is going to be 10, and we're still storing it in our max variable. But now we're passing that into our function called print stars. So this print stars function gets, we know that this is going to return 10, so we're passing in the value 10 to print stars. What does print stars do? Well, if we go down here, it's just printing out, well, they're really asterisks, I guess. And we know that 10 was passed in from the main in this particular case. So its variable int, or parameter int number of stars, is going to contain 10, and that's controlling the loop. So this is going to print out 10 stars, right? That while loop is going to print out 10 stars. And this function, it's not returning any answer or any value. It just kind of finishes. There's no more code, and the function finishes. It's not returning anything because it's a void function. So when that code finishes, execution just, you know, resumes back here. We got to this line, it jumped to the print star function, it executed that, and now it jumps back to execute the next line in main, all right? It goes back to the main function and continues on after the line that called the function. Now, on this next line, we're calling the print warning function. So it's going to jump down or jump to that particular function and start executing it. So when we go down to print warning, all right, we don't actually supply it any input. It's not returning any value. It's just doing something. And in this case, it's just printing stuff out. When it finishes executing these lines, and it's done, when we finish our function, it always just goes back to the line after that function when it was called. And in this case, we now do a return naught from the main. It's returning a value, and the function, the whole program's over. So we're jumping to functions, we're coming back to the line after it and continuing to execute. And yeah, this is just an example of void functions, void inputs, void return types, and, you know, showing you ones that aren't void as well. So this is what the whole program does. Now, I guess one of the key things to note is this maximum function is not printing anything out. It's returning a value to us, and we're never printing out the value 10. It's returning something to us so we can use it in some way. So I think when people get started, they sometimes think, I can just print it out in the function or something like that. But anyway. The other thing is, if I've got a function with a return type of void, I can't do something like this. It's not returning any answer that I can assign to something. And if I've got a function with void input, I just do these empty brackets. Okay? All right, are there any questions about functions? Like, we're going to do a lot more with functions, but any initial questions you've got now? Yep.
What does the print stars function do?
Oh, this print stars function, if we go and look at it, this is just a loop, and it's just printing out stars. So it's a while loop. It's going to start at I is equal to 0, and it'll print out a star. Then I will be equal to 1, it'll print out a star. I will be equal to 2. And the number that it gets passed in determines how many stars it's going to print, right? So if I passed in print stars, let's call it again. I could just say, let's go and print 100 stars. And it's got a loop in there. It's going to go print 100 stars. I'm not going to count them, but that must be 100 stars. Okay? And I could print that warning as many times as I like. You know, these are reusable functions. I can get a whole mess if I do this. Woohoo. Okay, any other questions?
Why do we initialize the function as void in the starting line?
So why do we have void? Void, if we've got the void here, this is a void return type. That means we're not returning any value at the end of the function. We're just doing something. So I'm just printing stars. I'm not returning some variable or some value, that I can use back in the function that called it. And if I've got void here, it means we don't need input to this function. It doesn't need any additional information to do what it needs to do. And in this case, yeah, it's just always going to print this thing. I don't need to tell it any more information to do this. Okay. So these are the basics of functions. Okay, I've talked about that. Okay, function comments and style. So every function has to have a comment placed before the implementation. And that's got to describe the purpose of the function and any side effects the function has. So the only side effects I could think that you'd have at this stage is that, a side effect is that it might print something out. So when you've called this function, it might do stuff, but it might print something out. So you'd talk about that. Make sure you choose meaningful names for your functions. So if I called this function like M, it makes it that much harder to work out what my program's doing. Does everyone agree? So maximum, as soon as I read it, I can imagine what maybe this function does. So don't start doing cryptic names like PW or something, write print warning or whatever it is. Okay. So look, we'll still have a quick 5-minute break, even though we started late. We'll have a quick 5-minute break to give your brain a little bit of a rest from that, and we'll come back and we'll do our own code examples of some functions. So just 5 minutes. Very good, very good. So we're going to write a simple function ourselves, and then we're going to clean up that print Pokemon sort of mess that I showed you earlier. So the first one's just a simple one. It's an area of a triangle. Let's go have a look. Okay. Oh, area triangle. Okay. Oh, I've got it in front of me. So we're writing a program to find the area of a triangle. To start with, I'm not going to use a function. Let's just write it. So we've been given the formula. So typically in computing, we don't expect you to have memorized all the sort of different equations for different things. I mean, a lot of you probably know this equation already, but don't start worrying that you've got to memorize all the sorts of equations for different geometry things. So we've got some variables, base, height. That's what we're reading in from the user, and we're reading in doubles. I want them to be able to say that it's 4.5 whatever's, centimeters, I guess. Doesn't matter. And then we're calculating the area. So what do I write here? Area equals what? So somebody's entered the base and height. I've got those in variables. What do I type in? So I've got my equation up here. I can do half times base times height. Anything that you think might not be great about this? Nothing to do with functions? Yeah, what are we going to get if we do this? Zero. So why are we getting 0? Everyone, why are we getting 0? Yeah, when we do this 1 divided by 2, 1's an integer, 2's an integer. When we do 1 divided by 2, we get 0. So this is like saying 0 times base times height. We're just going to get 0 no matter what. If I do something like 1 divided by 2.0, then I don't get 0. Or in this case, I could just type in 0.5, right? But if you just type integer 1 divided by integer 2, you're going to get 0, and you'll often be left scratching your head wondering why. Okay, so I've got the area. Does that look right? The number one rule when you're testing your functions or programs is know what the right answer is supposed to be. Yes. All right, now, if I want to put this into a function, what name should I call this function? The function is going to calculate the area. What do we want to call it? Area triangle. And actually, that's what I called the file name. Okay, perfect. We don't want to call it A or even just area, because anyway. What's the inputs going to be? Yeah, so I need to pass in 2 doubles. A double, gosh, I can't type, can I? double base, double height. We don't have to call it base and height. I could call it x and y. It doesn't have to be the same as the variables I'm using in here. But if I call it x and y, that's not very meaningful. So I'm going to call it base and height again. And what type is it going to? Yeah, double. Very good. Okay, so now we've got to actually implement it. We've got our prototype done. I'm going to implement it down here. And really, I'm going to do something very similar to what I did up here. Oops. So this is my function. And in fact, I could even just do it on one line and just say return 0.5 times base times height. But I'll leave it like this for now. Now up here, instead of doing my calculation, I call area triangle and I pass in base and height. And this is how it all fits together. Now, some of you are wondering, maybe, was this really worth writing a function for? Is anybody wondering that? Or no, everyone, good. Oh, good. It's good to have the function, even though this is a short function, because you know that bug about how we accidentally did 1 divided by 2 giving us 0. That's so easy to do. It's better to do it once, debug it, and then not accidentally do that at another time when you try and get the area. And you don't have to, when you're looking at the main, you don't have to go and see all the extra details of 0.5s and stuff like that. And you might be doing this calculation a lot. Okay, does it still work when we do it like this? I hope so. We should test it more thoroughly than that though. So when you start with functions, so when you do your assignment, I believe you've got an assignment coming out next week sometime, your first assignment. If you find that you've got code that's getting really long, or if you find you've got code that you're copying and pasting and duplicating, you might think, oh, I need to put that in a function, right? So you could do something like that, pull it out and put it in a function. Sometimes you'll know in advance, you might be able to plan in advance, maybe I'll write this function. But to start with, if you're a beginner coder, maybe you won't, maybe you'll just see as you're duplicating code, ooh, this is a sign, I should pull it out and put it in a function. Okay, so that's a simple function. Let's go to a messy situation. Now, don't worry so much about every detail in this. We're going back to our Pokemon example. We've got our struct Pokemon. I've created a Pokemon with the variable name Jigglypuff. I've set all the members inside that struct, and then I've just tried to print out the details about Jigglypuff. And it looks like this, and yeah, this repetition of code is just a classic sign that you should have a function. So there's 2 functions I want to write, but the first function that we could do is we could have a function that can print out a Pokemon type. So we don't have to copy and paste all of this and just change it slightly every time we want to print out the details of a Pokemon. So if I want to print a Pokemon type, I mean, I can call it print Pokemon type. What's my input to this function going to be? This is a tough one. Sorry? Well, what type is our Pokemon type? That's a good question here. When I'm comparing this to fairy, what type are we dealing with? Well, what type is the actual fairy, fire, psychic? What type's that? But what's the type we're using for our variables? Yeah, enum Pokemon type. This is the type. So if I'm using an enum type, let's go back to weekday, if I've got it. Enum weekdays. Just say we've got this simple situation here. I declare a variable called day, and it's of type enum weekdays. We know behind the scenes it's kind of really stored as an int, but we've got this type that we declare variables with, enum weekdays. So we want to put that in as the type, not weekdays, but Pokemon. So, wrong file, here we go. So the input type is going to be enum Pokemon type, basically this. So, and we give our input a name. So the user gives me a Pokemon type, and I'm going to print it out. What return type do I have? Void. I'm not going to return any kind of value or answer. This is like giving orders. Go and print out this Pokemon type. So we should give it fairy, the enum fairy, and it should print out the word fairy for us. Printf the word fairy, for example. So how are we going to do this? That's our prototype. Let's go and try and write it. Now, this is where we have all the if statements, right? If type equals fairy, print fairy. I'm not going to make you watch me do that. I'm going to go and take this kind of code. This is kind of exactly what we want. But my variable name's wrong. I want this just to be type. Right? So I'm going to change all these at once. Okay. All right. So, you know, if my type's fairy, I print fairy. If my type's fire, I print fire, etc. Is everyone happy with that? And this is code. Given a Pokemon type, I can print it out in nice words rather than just printing out 0, 1, 2, 3, 4, 5. Is everyone happy with this? Okay, now up here, instead of having to repeat all this code all the time, I can use my function. I can say, let's print Pokemon type, and I can pass in the Pokemon type I'm interested in, and that is Jigglypuff's primary type. I don't have to do all these if statements again. I just say print Pokemon type. This is the primary type of Jigglypuff. Will you print it out for me? Then I can say print Pokemon type. Here is the secondary type of Jigglypuff. Will you print that out for me? And I get to delete all of that horrible repetitive code from my main function. And all of the logic and the horrible code, I just have to write it once in this function, and then I can use it anytime I want to print out the type. And this becomes very useful for this kind of repetitive code. Who thinks this function looks better already? It's more readable. I can just kind of read it. Print Pokemon type, Jigglypuff primary type. Now, I could also make another function just to print a Pokemon, right? Especially a real Pokemon might have more details than we've got here. So I could have void print Pokemon. What type is this taking in? It's going to be void because it's just doing something. What's the input I've got to give it? What type? So I'm trying to print out stuff about this Pokemon Jigglypuff. It's the struct Pokemon. So I can pass in a whole Pokemon and the function can print out all the details about it. Well, if I write the function. I'm just calling my variable my Pokemon just so we don't get confused. And again, I'm going to take all of this stuff here, put it in here. But of course, when I do that, all the variable names are a bit wrong because in my main, I called my variable Jigglypuff, but this function is supposed to work for anything and we call the variable my Pokemon. So I'm just going to change this variable here. Okay. So this, any Pokemon you print in, you could have a struct Jigglypuff, you pass it in, it prints out the stuff about your Jigglypuff struct. You could have struct Pikachu and pass that in and it'd print out the details for that particular struct Pokemon. Then up here, oh yeah, I've got to actually call the function. That's another thing. If I just compile this now, and this might be obvious to some people, but some people will actually get confused about this at some point, I promise you. What are we expecting the program to do? Oh. If we ignore this warning and run it, what's our program going to do? Yeah, it's just going to print this. Just a reminder, just when you write a function, sometimes people write their function and then they run the program and they think nothing happened, nothing happened. You've got to actually call the function and use the function. So I've seen lots of people do that. Okay. That's right. So I'm calling my function. It's one line instead of a million lines, like the main function, and it does all the same stuff. So I hope, even if you didn't understand every line of code in this, because this is a very complicated example, we've got structs, enums, functions, all sorts of things. We're putting a lot together. But hopefully you can understand the benefit of having functions after seeing this example. Is everyone, yeah? Okay. All right. Oh, we've still got time. So now we can talk about some of the finer details of functions. Okay, so this stuff, we're getting a bit technical here. So have a moment to let your brain wander or relax and then, you know, come back to focusing. So, we need to talk about memory and scope. So now we've got variables in we've got variables in our main function, we've got variables in these other functions we're writing. How does all of that work? So we've got things called blocks of code. So when we start an open curly bracket, that's a block of code. And when we do the close curly bracket, that's the end of the block of code. So let's have a quick look at just something, maybe not something so, yeah, let's save that. Okay, even this code here, this is a block of code, right? This is in one block because it's between an open curly bracket and a closed curly bracket. This is a second block of code down here. These are two separate blocks of code. Why does that matter? Well, when you declare a variable, that variable can be used from where you declared it to the end of that block. And anytime you declare a variable inside a function like that, we call it a local variable. So over here, this double base and height and area these are local functions within this main function. This is actually a tricky example because down here we've also got base, height and area, and these are local to this area function. These are two separate copies of variables. I'll show you a better example. Okay, and let's just get rid of this one for now. So I've got a function here, and this particular function, let's draw it out. And I'm going to draw a line here because this is one block of code. We've got the local variable called n, which lives like it's one of main's variables, and it's got the value 5.5. I've got answer, which has some value in it as well. And let's go through this function call as well. So I've got two local variables in main. They live in an area where main's variables live. I'm getting to this line here and I'm about to call a function. I'm passing in n, which is 5.5, into this function, and 1.5 into this function. So this add numbers function is now executing, and it has its own set of inputs and local variables itself. So it has an x variable and a y variable. These are we call these parameters actually, but these are the inputs. So the x, what value does the x have? We're calling the add numbers function. We're passing in n and 1.5. Yeah, so when we call the add numbers function, the value of n, which is 5.5, gets passed into x, right? This is 5.5. This is 1.5. So we got these are the two inputs from our function that was calling this function. Is everyone clear on that? We pass in those values. In our add numbers functions, where they're in x and y. That's what they're calling it. They're the variables they're stored in. We've also got just another local variable called sum. So all of these are accessible in the add numbers function. None of them are accessible in the main function. The main function has these variables. They're like the n and the answer variables. They're accessible in the main function. We can't access them in the add numbers function, and I'll show you that in a minute. So down in the add numbers function, we're saying sum equals x plus y. So we're going to get, what do we get? Everybody? X plus y? Yeah, good. We get 7, and that's in this local variable, but then we return it. So we return this value of 7. Where does it get stored? In the main? In answer, that's right. So we'll end up with answer here in this. And actually, when this add numbers function finishes, the system doesn't need the resources for this anymore. That function's done. It's as though they never even existed. And we're back to the main that still has these variables because the main's still running, and it continues executing in the main. It's going to print out the answer is 7. Okay? So the key thing here is the variables that you declare in main, they exist within this block of code. The variables in here exist within this block of code. So if you try and do something like this, printf, oh, that would be the wrong type, answer, the compiler is going to say, what is answer? You don't have a variable called answer. Oops, I've done the wrong. Okay, error, use of undeclared identifier answer. This is because answer only exists in the main function. Is everyone clear on that? It's a local variable. If we do the other way around, if we try and in here access x or something like that, it's going to complain and say, what is x? Now, the thing that sometimes confuses people is sometimes we can have some of the same variable names in two different places. So down here, I could be calling this x, right? If I'm calling this x and passing in x, then I've got an x that's up here, and I've also got an x that's down there, right? In this situation, I've got an x that's here, down in here, I've got another x. So when I pass in, this is 5.5, this is 1.5, I add them together, I'm still going to get 7, and I return it. But these are two separate variables. Does this matter? Yeah, it does matter because, you know, down in here, for whatever reason, just say I do the sum, and then for whatever reason, I say x plus plus. Oh, we don't know what that is. X equals x plus 1. I'm incrementing or adding 1 to this one. Can everyone see that? I'm adding 1 to the x, this copy of it. The x back in the main still has 5.5 in it. Can everyone see that? So I've got two copies, right? They're separate variables even if they've got the same name sometimes. Okay, let's just show you that that actually happens. So x in my function, let's print that out. Oh yeah, I can just say x in main. Okay, so we can see that in the function, we've incremented x, we've added 1 to it, and in this function it equaled 6.5. But back in the main, this is a completely different x. It was a completely different chunk of memory, and its copy is still 5.5. So even though we can sometimes even have the same names in different functions, they're not the same variable. They're separate things. Does that make sense? Okay, one more concept. So that's memory and scope. That's local variables. They're only available in the block that they're used in. Typically, a function is a common example of a block, but you know, while loops and stuff are blocks too. We've looked at that. This is a local variable. Now, the other type of variable that we don't want you to use is something called a global variable. Has anyone heard of global variables before? People have heard of global variables. Have you done other programming? And what did they say about global variables? Unsafe. Unsafe, don't use them. Yeah, so we're going to say that in this course as well. Global variables are ones that aren't declared inside a function. They're just outside, and they can be used by anything. They can be just used anywhere in the program. Why is that a bad thing? That sounds like a good thing. Like it can be used anywhere. Why is that bad? It's kind of like having your food in a communal fridge, right? And you go back to get it and it's gone. You don't know who's taken it. or who's taken a bite out of it. So with a global variable, any function that has a bug in it could be, you know, destroying that value. It also, you know, functions might have a variable with the same name as the global variable, then that gets confusing. It can add a lot of confusing. It makes code really hard to read and debug. There are some other more technical issues that make it bad in other situations as well, but they're the main issues for us. So it makes it much harder to debug your code if you've got these global variables that can be changed anywhere. Yep.
So if I define a global variable in the top of the program, then I have the same name as a local variable, maybe the main function. So when the compiler compiles the program, they will recognize the variable as what? As the global one or the local one?
Oh, we've got a question here about if you do have a global variable that has the same name as a local variable, what one will it think you're using if you're printing it out? The thing is, we don't even want to know the answer to that because we don't want to use global variables, but you can try it out. You can try it out. Actually, we can. I'm going to demonstrate the global variable in a minute. It should probably give you the local variable will shadow it, so that's why it becomes actually confusing. Yep.
I just want to say, I'm pretty sure global variables are also bad for module testing because then you can't test the standalone modules because they are kept being passed through all the subroutines, so you can't test them individually without having to have a global.
Yeah, the other reason is, yeah, it can, you know, if you wanted to test, sometimes you might set up a testing framework where these global variables aren't helpful as well. So there's lots of reasons. For us, it's mainly anything can change it, and it's hard, it makes a mess. So let's have a quick look, because we don't want you to use global variables, but some of you might have already tried to use global variables, right? You might have thought, I need a variable called, I don't know, X. That's such a bad name. No, we've got too many variables called X. We don't want that now. I need a variable counter. And you just might start typing it up here, and maybe the compiler doesn't complain, and you just think, yeah, well, that's how you type in a variable. And maybe you haven't even thought about whether it's inside a function or not. So now you do have to think about that. If you've just happened to declare it up there, because you didn't even realize, that's a global variable. It needs to be inside the function. Otherwise, it's bad style. I believe the C style checker will pick up global variables. Is that correct? Yeah. There might be, has anybody, look, you might see a style checker that will help you and tell you you've got global variables, but also don't use them. So just to show you though, if I have a variable called num up here and I give it the value 99, I can use num anywhere, right? I can use num here. Oops, gosh. I could use it anywhere in either of these functions. Okay, I can use it anywhere. And the problem is, maybe in this function add numbers, it's gone and done something to num, right? And now suddenly, back in main, it might have, the person programming might have looked up, seen that num's 99. Okay, I'm relying on it being 99, and not realize somewhere buried in a piece of code in another function, that value's changed to 0. And if you've got lots of code, that can really make your life difficult, trying to work out which of any line in your 1,000 lines of code might have changed that. It becomes really annoying and messy. So we're not going to do it, but we want to show it to you so you know what it is, so you don't do it, because otherwise you might accidentally do it. Okay, we don't have long to go, but we've gotten through actually a lot. I'll come back to these finer points. I think there's enough finer points today about functions. I'll do them tomorrow. Let's have a quick talk about style. And we'll continue talking about style all the time. So does everybody understand why we want good style for our programs? This is important because you've got an assignment coming up soon. And in your assignments, you get marks for style. So your code will be auto-tested, and a human will look through and look at all the style things. Now, has anyone taken a look at the style guide? Yeah, so people know about the style guide, which is good. In case you don't, so there is this automatic 1511 style checker. So you can run your code through this style checker to get feedback, but it won't be able to pick up everything that a human might pick up when they're marking it. So you do need to be aware of it. Okay. Yeah, we've got a couple of minutes. I'll talk more about style next time as well. And I'll show you an example of really, really horrifically bad style that we can all agree is terrible, and promise we'll never do anything like that ourselves. Thanks everyone for your patience today with the tech issues. I really appreciate it. See you online tomorrow.